The air conditioning in your car is not broken. The compressor is fine. The refrigerant level is correct. The system was engineered to perform exactly as it did the day you drove it off the lot. And yet every summer, somewhere between June and August, you notice it. The air comes out weaker. The cabin takes longer to cool. You turn the fan to maximum, and the difference is marginal. So you take it to a shop. They tell you it needs a recharge. They quote you $180, maybe more. What they do not tell you is that the actual problem costs $4 to fix. It takes between 5 and 10 minutes. It requires no tools beyond your hands, and it restores the cooling performance of your air conditioning system to factory specification almost immediately. The component responsible is not in the engine bay. It is not part of the refrigerant circuit. It sits behind your glove compartment, and in most vehicles it has not been touched since the car was manufactured. And the reason most drivers have never heard of it is not because it does not work. The cabin air filter as a standard equipment item in passenger vehicles has a documented history that begins in the early 1990s. European manufacturers, Mercedes-Benz and BMW among the first, began integrating particulate filters into HVAC intake systems as a response to growing urban air quality concerns. Aftermarket filters that meet OEM specifications are produced by dozens of manufacturers and retail for between $4 and $15. There is no marketing budget behind cabin filters because there is no margin in marketing them. The dealership service department, however, charges between $60 and $120 to replace the same component as part of a service interval, when they mention it at all. The economics favor silence. The filter that costs $4 at an auto parts retailer is the same filter, often from the same supplier, that the dealership installs. When that filter clogs, and after 30,000 or 40,000 kilometers in normal driving it will be clogged, the consequences are direct. The blower motor pulls air through a restricted element. Airflow into the cabin drops. The evaporator core, which is sized to cool a specific volume of air per minute, is now seeing a fraction of that volume. The air that does pass through is cooled, but there is not enough of it to cool the cabin effectively. To the driver, the system feels weak. The natural assumption is refrigerant loss. The actual cause is upstream of the refrigerant circuit entirely. If you are still with me, you now understand something the average driver does not. You know that a weak air conditioner is not, in most cases, a refrigerant problem. You know that the diagnostic the dealership offers is often pointed at the wrong component. By the late 1990s, Japanese manufacturers had adopted the same architecture, and Toyota, Honda, and Nissan began equipping cabin filters as standard across their domestic lineups. By 2000, the cabin filter was effectively universal in new vehicles sold in developed markets. The filter itself is a pleated paper or synthetic fiber element designed to capture particulates from the air entering the HVAC system. Its specifications are documented in SAE technical literature and in OEM service manuals. The filter is rated to a service interval. That interval is the part the consumer is rarely told about clearly. Toyota's domestic market service documentation specifies cabin filter replacement at 15,000 to 20,000 kilometers under normal conditions, and considerably shorter under dusty or urban conditions. Honda's specification is similar. The filter is treated, in the Japanese domestic market, as a routine wear item, replaced at the same frequency as engine air filters, often by the owner. In the export market, the same component is frequently absent from the standard service schedule entirely. Many Western owners' manuals mention it only in a parts list, with no recommended replacement interval at all. This is the gap, and it is not a conspiracy. It is something simpler and more documentable. The cabin filter is not a patented component. There is no proprietary chemistry, no exclusive manufacturing process. If this is useful to you, subscribe to this channel and share this video with someone whose AC has been struggling this summer. They are about to spend $180 on a problem that costs $4 to solve. But stay here, because what happens at the evaporator core when that filter is clogged is worse than reduced airflow alone. The cooling capacity of an automotive air conditioning system is governed by the heat exchange that occurs at the evaporator. Refrigerant in the evaporator absorbs heat from air passing across the fins. That heat exchange is a function of three variables: the temperature differential between refrigerant and air, the surface area of contact, and the mass flow rate of air across the core. The first two are fixed by the system design. The third, mass flow rate, is determined by the blower and by the resistance of the intake path. A clogged cabin filter increases intake resistance substantially. Independent HVAC testing documented in automotive engineering literature shows that a filter at the end of its service life can reduce airflow through the cabin system by 30 to 50%, depending on the contamination load. This is not a marginal effect. A 40% reduction in mass flow rate translates directly to a 40% reduction in the rate at which heat is removed from the cabin. The system is doing the same work per unit of air. There is simply far less air. There is a secondary consequence. Expect to pay between $4 and $15 for a standard particulate filter, or between $15 and $25 for an activated carbon filter that also addresses odors. Both restore airflow equally. The carbon variant is optional. The filter housing in most vehicles is located behind the glove compartment. The procedure: open the glove box, release the dampener arm or the side stops so that the box drops fully, and you will see a rectangular plastic cover. Release the tabs, slide out the old filter, note the airflow direction marked on its frame. Insert the new filter in the same orientation, replace the cover, and reseat the glove box. In some vehicles, the housing is under the dashboard on the passenger side or behind a kick panel. The owner's manual specifies the location. The procedure takes 5 to 10 minutes the first time and 2 minutes thereafter. Replace the filter every 15,000 to 20,000 kilometers under normal conditions, or every 10,000 kilometers in heavy urban or dusty environments. Inspect it visually at every oil change. If it is gray, dark, or visibly loaded with debris, replace it regardless of mileage. The cooling improvement is immediate. You will feel it on the drive home from the parts store. The procedure does not affect your warranty. The cabin filter is a designated owner-serviceable maintenance item in every modern OEM service manual. Replacing it yourself is explicitly permitted and expected. Total material cost: $4 to $15. Total time required: 10 minutes. With reduced airflow across the evaporator, the core runs colder than designed. In humid conditions, this can promote ice formation on the fins, which further restricts airflow. In severe cases, the evaporator freezes over completely. The compressor continues to cycle, the cabin gets warmer, and every minute of operation in this state places additional load on the compressor clutch, the blower motor, and the evaporator drain. None of this damage is necessary. All of it traces back to a $4 filter. Fleet operators who maintain large vehicle pools, taxi fleets, rental companies, municipal vehicle services, track cabin filter replacement on the same interval as oil changes, precisely because the operational cost of ignoring it compounds. Vehicles in fleet service that follow scheduled cabin filter replacement show measurably lower rates of HVAC component failure, longer compressor life, and consistent cabin cooling performance across the vehicle's operational lifetime. The vehicles that arrive at the end of a lease cycle with original equipment cabin filters still installed are the same vehicles that have been quoted for refrigerant service 2 or 3 times in the same period. The filter you need is specified by your vehicle's make, model, and year. Any auto parts retailer will look it up by the vehicle. Brands like Fram, Bosch, K&N, Man Filter, and Denso all produce filters that meet or exceed OEM specification. The equivalent dealership service, $60 to $120 per visit, recommended every 15,000 to 20,000 kilometers when they mention it at all. The cabin filter has been standard equipment in passenger vehicles for more than 25 years. The replacement procedure has been documented in every OEM service manual published since the late 1990s. Fleet operators have treated it as routine maintenance for decades. The information has always existed. What has not existed, in most consumer markets, is the bridge between what the technical documentation says and what the average driver is told at their next service appointment. That bridge is what this channel is built to provide. If this changed how you think about your air conditioning system, subscribe. Share this video with anyone who has been told they need a refrigerant recharge this summer. There is a strong chance they do not. In the next video, we are going to look at the refrigerant itself, specifically why the R12134YF systems in vehicles built after 2017 lose cooling capacity faster than the older R134A systems they replaced, and the single inspection point most technicians skip that determines whether your system will still be cooling properly 5 years from now. You will want to see that one before your next AC service.